Golden Valley is a member-owned RUS cooperative headquartered in Fairbanks, Alaska, which is the northern end of the Alaska Rail Belt transmission network. We take our responsibility seriously as the only utility serving the interior of Alaska.
We have a pretty big Department of Defense footprint in our service area, and the result is that the Department of Defense is very interested in how we do our cybersecurity. We try to keep that relationship going, obviously. Cybersecurity standards require passwords that can be changed, say, every 90 days or so. So our end devices at our substations needed to meet that standard. Being able to automate that and being able to document the fact that we're changing our passwords is essential, actually.
We were looking for a methodology where we could apply those standards to our substations. We almost exclusively use SEL products for our relaying and protection, and it made sense to go with a product that came ready to work with our SEL relays. SEL worked with us to come up with a solution tailored to our needs here and the size of our utility. We are using the SEL security gateway at each substation paired with an SEL RTAC. The RTAC is connected to each of the IEDs, our relaying and protection equipment. All connections to the substation are routed through this central host that allows permissions for who's connecting on there, and then that central host does the communication through the 3620 to the RTAC to the device.
That system takes care of the password management of the end devices, and the user doesn't need to know what the actual password is.
When there's a disturbance event on a system, the IEDs automatically generate their event reports, push those reports back to that central host computer where they're stored in a database with the software platform.
With the automatic event retrieval, if we have a call out where we have to go off to a transmission sub that's, say, 2 hours away, with that event already in a database that our engineers can go and look at, they can start analyzing that event. And by the time that we get there, they might already have a solution in place instead of us sending it off to them and waiting for them to look at it.
The documentation with any engineering project is critical. SEL was flexible and open and willing to work with us on a design that made sense for our application. We went through multiple iterations of developing the layout, the topology, the architecture for the networking and the security settings, and that was all done in the format of exchanging a design document. There was a separate document that SEL produced, which was site commissioning instructions, and those two documents became key to the project.
The final document that we've gotten from Schweitzer provides all the networking information and how it is at the sub in a really readable format. And the very end, it actually gives us instructions on how to make changes when we need to. Schweitzer has really been there for any questions that we might have. We get a pretty quick response on it.
This project is really a foundation for allowing that we can expand out easily without having to rethink each time we're doing this. It's an exciting future, a great time to be in the power industry. We have a lot of responsibility to improve the quality of people's lives, and SEL has really helped us and is helping the power grid in general move us in that direction.